proceed from here, from that point to go to the twin part, which is the logarithms. And therefore, I want us to look at these logarithms, and we look at also some computations. So it was indices and logarithms. So just briefly, what is logarithm? And then we move on to practical computations of this.
Sir, pardon, but I have a question.
Yes.
Okay, for the exercise you gave us, number 8, which was 2 raised to n plus 2.
Just a moment, let me write somewhere because it's the another slide. Exercise is 2
raised to n plus 2.
2 raised to?
It was 8.
Okay, just a moment, let me come to it. Let me search for it among this one, then you can now tell me which one it was. Please control your mind. Was this solving equation, my sister?
Umeipita iko hapo juu kidogo.
It was? Is it in this area? Hello, was it in this area?
Nasema umepita mwalimu.
Huh?
It's from exercise 5.3.
Yeah, 5.3.
Simplify.
Yeah, this is number 8. Please.
Number 8.
Yeah.
Okay.
Oh.
You're asking what the question was simplified, isn't it? So where is the issue, my sister?
Actually, I wrote the question wrong. Maybe that's why it was hard for me to calculate.
You wrote the equation?
Excuse me, sir. Excuse me, sir.
Or you did not write it well?
Not write it well, sorry.
Or you don't write it well, eh?
Yeah.
Excuse me, sir.
Okay. Rewrite it, then now you can continue.
Excuse me, sir.
Yes?
Can you kindly explain more about that question? Because I also had a problem in solving that question.
Oh, this number 8.
Yes.
You know, we know that 2 raised to power 2 raised power n plus 2 minus 2 raised power n. Plus. Why don't you control your microphone? Are you getting me microphone, please? If you want me to, otherwise I'll switch off, do something again. 2 raised power n plus 2 minus 2 raised power n plus 12 into n minus 1. Please, if you want me to explain, can we keep silence? Now you're asking what is the relationship between 2n plus that? This is the same as writing 2 to power 2 times 2 to power n minus. Let me keep quiet. Kevin.
Let's get now.
Quiet, Kevin. So are we all ready to learn now?
Yes.
Yeah, because if you don't want us to delay, because you know very well we are in class, you should mute all through. Now you are making the noise and you want me to explain. How do I explain? That will confuse atmosphere. I am saying this is same as 2 raised power n times 2 raised power 2. Is that true?
Yes.
Minus 2 raised power n plus 12 is the same as 2 raised to power 2 times that, or 12 is the same as 3 times 4. So what do I have here in this case? I can still write as 2 raised to power 2 times 3 into 2 raised power n minus 1. So the first part is that 2 raised power 2 and times n minus 2 raised power n. There's a common factor there. There's a common factor there, which is 2 raised power n. Is that true?
Yes.
Yes.
So I can put it 2 raised power n outside, then the other side is 2 raised to power 2, which is 2 raised power 2 minus 1 plus. Again, I have 2 raised power 2 times 3 into n minus 1. So if you now expand, this I wanted to continue because you said, yeah, if you now expand, first of all, 2 raised power n into 2 squared minus that. Inside there is 3. Is that true? Two raised power 2 is 4 minus 1 is 3. Is that true? Maybe we have lost each other.
Where is it? Where are you saying 3?
My friend, 2 raised power n plus 2. Have I said 2 raised power n times 2 raised power 2? Is that true?
Yes.
Hey. And 2 raised power n, what's the common factor? Is it not 2 raised power n outside?
Yes.
And if it's 2 raised power n outside, then inside 2 squared minus 1, which is 4 minus 1, 3. So this part, the whole of it comes into 3 times 2 raised power n minus 12 into 2 raised power n minus 1. Again, if I look at 12, there's connection between 3 and 2 in that we have 12 the same as 3 times 2 squared. Is that true?
Yes.
Or if I don't mind, 2 raised power n minus 1 the same as 3, the first part, this part becomes 3 into by times 2 to 2 raised power n plus 12 into 2 raised power n over 2. If I have 2 raised power n minus 1 the same as 2 raised power n divided by 2, is that true? Hello? 2 raised power n minus 1 the same as 2 raised power n divided by 2 raised power 1, which is 2.
Yes.
So the first part I have 3 times 2 raised power n minus 12 over 2 is 6 minus 6 into 2 raised power n. Please, this part we have simplified to 3 times 2 raised power n. Is that true?
Yes.
Now, 2 raised power n over 1, I've said same as 2 raised raised power n divided by 2 raised power 1. So 12 will be divided by 2. Just a moment. Hello? Morning. Yes.
Cha kuna kitu naelewa, kuna
Huh? Please call me later. I'm in a class. Yeah. So this part, sorry, a parent was calling me, we have to respond. Class, we are the first two terms, this and that, reduce it to 3 times 2 raised power n. Is that agreed?
Yes.
Then
Okay, where's
this,
that coming from?
Excuse me, sir. Why don't you use a paper and a pen so that
Yes, Mwalimu, you're not understanding, ba.
let me have order. No, listen.
We need to show the.
It's like you are doing it pure.
kindly just use some piece of paper
Okay,
and a pen.
you talk up to, and then I listen to one person.
Yeah,
Hey.
I'm talking and I'm saying.
Until now, you tell me one person talking. Because
Yeah,
writing.
kindly allow me talk. Kindly allow me talk.
Yes.
So we are requesting that for this one, you at least use some piece of paper and a pen so that we can see.
What I'm saying, listen to instruction.
Yeah.
We did lots of indices. Is that true?
Yeah.
What is 8 power m times 8 power n?
8 power n times 8 power n. That is why we need you, sir, to put a pen.
We did that one.
If the base is the same,
power
if the
m.
base is the same, then we only add the indices.
No, just a moment. Just a moment. I don't want us to have in a quarrelsome situation. We did indices, lots of indices. Is that true?
Yes.
Yes.
What is a raised to power m for Mombasa, times a raised to power n for Nairobi? What is the answer?
8.
Pardon?
Again, pardon. One more pardon. A raised to power m times a raised to power n. What is the answer?
A raised to power mn.
A raised to power mn again.
A raised to power m plus n.
Yes, tomorrow we have a first quiz. That is rule number 1 we did. So if we are moving forward and backward, that's not learning. Now, a raised to power m plus a times a raised to power n is a raised to power m plus n. Listen, yes. We are not a shouting match. We are not in a Man U and Arsenal. This is 2 raised to power n plus 2. And I'm asking, is it not the same as 2 raised to power n times 2 raised to power 2?
It's the same.
It is the same.
Good. It's the same. So I have 2 raised to power n plus 2 written as 2 raised to power n times 2 raised to power 2 minus 2 raised to power n for these two parts. Is that true?
Yes.
Yes.
In algebra, is there a common factor there? If I leave this part only, is there a common factor there?
Yes.
Which one is it?
2.
2 alone?
Raised to power n.
2 raised to power n. Put it outside. Next step. 2 raised to power n into now 2 squared minus 1. These two terms. Is that true?
Yes.
When I speak, you should be writing, the idea that you must be writing, we are not robots to copy. I'm explaining what is there from the root of indices. So when you say yes, now it reaches a point now it is not, no sign, no response. It defeats logic because some things are now just staring on the screen. Step 1, this is the same as 2 raised to power 2 n times 2 raised to power 2 minus 2 raised to power n. plus 12 into 2 raised power n minus 1. Step 2, factorize. 2 raised power n outside, inside here will be 2 squared, here is 1. 2 squared minus 1. And 2 squared minus 1 is what?
Nimeona kalamu hapa, hii kalamu ni ya kazi gani?
Just continue naona kalamu, that we could quiz tomorrow. What is 2 squared minus 1? It is 3. So the next step, plus 12 into 2n, rule number 2, power n, 2 power n minus 1 is the same as 2 power n divided by 2 over 1. 2 power 1. 2 power 1 is 2. So I have 12 divided by 2, 6. Third step is going to be 3 into 2 power n plus 6 into 2 power n. Like terms, 3 plus 6 is 9. The answer becomes 9 2 raised power n.
Yes.
That's okay. So, you know, when you deliberately refuse to read, to think and talk, then we go nowhere. So we are talking about logarithms. When we have the eyes to see, let us use that organ of sense. Let us not behave like mob. I believe you are able to see the screen, are you?
Yes.
And all of us, I believe, are able to read.
Yes.
You know, maybe
Yes.
seeing and not able to read. Therefore, we are defined what an index is. We are now defining what is logarithm. An index is where before we look at the explanation, I want to write this in your notebook somewhere. What is 100 in terms of the powers of 10? It's the same as 10 times 10, which is 10 squared. Is that true?
Yes.
I'm deriving something. I know there are those who are waiting. Please pardon. I've started from the simplest mathematics of primary school. 100 is the same as 10 squared. Is that true?
Yes, it is.
1,000 is the same as 10 cubed.
Yes.
10,000 is the same as 10 raised power 4.
Yes. True.
So when we write these numbers, we have left-hand side the whole 100 equals 10 squared, 1,000 equals 10 cubed, 10,000, 10 power 4. So we are saying the right-hand side is in index form, the left-hand side is the whole number. So we can say that logarithm to base 10 of 100 is 2. What does it mean? When I raise 10 to power 2, I get 100. Therefore, that index is what we are calling the logarithm. That exponent is what we are calling logarithm. Similarly, logarithm to base 10 over 1,000 is equal to 3. Now, I want you to look at your scientific calculator. What is common logarithm? That is log of 100. What does it show you?
2.
2. What is log of 1,000?
3.
And what is log of 10,000?
4.
4.
So we are saying logarithm 2. Is this the explanation now? Logarithm to base of y, base of x, of y of x. Or we are saying that if I have a number such that we can express an index. The index is the logarithm, the base is the base you are using. So if I use at this one, I can say log to base y of x is c. In index form is the same as writing y to power c equals x. I've said log to base 10 over 100 is 2. That's the same as 10 raised to power 2 is 100. Log to base 10 over 1,000 is 3. That's the same as 10 raised to power 3 is 1,000. This is the general form of that. So I say log to base y of x equals c, or in index form, y to power c equals x. That is the meaning of logarithm. The power to which, the index to which you raise, this is what we are saying. Technically, logarithm of a number to a given base is the value of the power to which the base must be raised in order to produce the number. This is what I'm saying. Logarithm to the 10 over 1,000 is the same as saying, this is what it says, the power to which the base must be raised. The power to which the base must be raised in order to produce that number is what we are calling logarithm. Let that sink into our sixth sense, if at all is there. The power to which you must raise the base to get a given number is what we are calling logarithms. Is what we are calling logarithm. If there are many, we call logarithms. And therefore, we have the twin topic of indices and logarithms. Indices we covered last time, logarithm we are covering now. And therefore, indices, we had what we call the laws of indices. We also have here the laws of logarithms, which are similar to the laws of indices, which are similar to the laws of indices. I have used a lot of words, so I believe my English is the simplest that. Laws of logarithms. That is most of our portion in this class. You watch, keep quiet, next class, please come again. Jesus said, do not be only hearers, but also be doers. So if I write this one and you're only watching, it's like somebody looking at himself or herself in the mirror. At the end of it, immediately you forget how you are looking like. Let us be doing some work and be sincere with ourselves. This is what I'm calculator? Well, I will not force you to have certificate because you need it by all means. There is a key marked LN. As a reminder, I'm not going to force you to do that because I think in math class, in high school, you're having the calculator. There's a key marks LN is read natural log only in N or log to base E. So we write it LN, not in, ln N, natural logs, the logs dealing to nature, physical quantities. And E, this number can be obtained as follows. If you have your calculator, press shift. Press shift if you have your calculator. Don't ask me to come again. You are supposed to have the calculator. Press shift, then press where it is in this place. Press shift, then press lane. There's a letter of the calculator there. Which letter is that? Now I know those who are sitting in this class and those who are more in the football stadium.
E.
E. Now that E, press 1 and press equal to. It will give you a number. Pressing 1 means E raised power 1.
2.7.
Does it give this kind of arrangement?
0.7 number means.
Yes.
Yes, 2718281 and continue, isn't it? This is the base.
Mwalimu, we have to grab this E.
Yes. I'm waiting, somebody was speaking. So we talk about natural logarithms, or sometimes we call it Napierian logarithms from the author John Napier. So that is what we call LN, ln N. That is from the author Napier, natural logarithms. So when we are going to look at this, we may have to calculate numerical values using common logarithms or natural logarithms. But in all, we are going to look at the general rules of these logarithms, and we have what we call laws of logarithms. Of logarithms. Laws of logarithms or rules of logarithms. Are you able to see the screen? We call them fundamental laws. There are mainly 3, just like we had for the case of indices. There are only 3, just like the case we had for the indices. So in this case, if I look at the indices, the similarity with what we have for the logarithms the same. Are you seeing the first law?
Yes.
Which is written addition dash product law. Addition dash product law. Which means it's also telling us what it is being done here. Log to base x of m plus log to base x of n is the same as log to base x combined now the product of the numbers. So what does it mean? We are saying when you are adding logs of two different numbers but of the same base, is the same as log of the product. So I want you to tell me, before you raise your hand, what is log of 2 plus log of 3, meaning to base 10? And the answer to 4 decimal places. Because many of us are very quick to raise their hand. Let's do practical work here. What is log of 2 plus log of 3? 4 decimal places.
It is log 10 base 10.
English language, numerical value. What is log of 2 plus log of 3? I'm working on the left-hand side. That is how understanding comes in. Don't be in a hurry to combine so many things.
0.782.
0.7782.
And what is 3 times 2? 6.
6.
Now, what is log of 6?
0.782.
0.782. Is that true?
Yes.
0.7782.
So they give the same value. I'm asking if I have log of 2 plus log of 3. You kill 0.78, no, 2, I don't know, whatever the value. And if I have log of 6, do they have the same numerical value?
Yes.
Yes.
That is what the law is saying, that if I'm adding 2 logs to the same base of 2 different numbers, it's the same as multiply those numbers, then finally getting their logs. That is how the rule is for simple illustration. And that is, remember, it is log to base x of m plus log to base x of n. The sign between here must be plus. It is not log to base x of m times log to base x of n. No. It is when I'm adding them the same as when I'm getting the product, then getting their logarithms. That is what it means. So we can look at, this is what it's telling us to be careful because these rows must be done. In other words, I hope you are still seeing the screen. Are you?
Yes.
Yes. Yes.
In other words, the sum of logs of numbers the same base, this is what I've just said, is equal to the log of the product and vice versa. The following should be noted about the rule. So look at that. It is saying, number 1, the logs must have the same base. Otherwise, the log cannot be used. Just like I was telling you the other time with the so-called indices. So that if I have log to base 3, base 5 of 2, plus log to base 3 of 8, it is the same as log to base 5 of 16. In other words, these are different bases. Neither is it the same as log to base 3 of 16. That is, I pick the other one. No. Again, number 2, the sign between the terms must be addition, as I'm just saying, and not multiplication. In other words, log to base 2 of 5, that is the same as log to base 2 of 5 times 10, which is 50. But if you get this one, we don't get the same value. That's what we are emphasizing here. Those are highlights that all of us will take note of That is law number 1, law number 2. Which is law 2 is what we call subtraction, quotient law. The other one, addition, adding logs of the same base, different numbers, the same as log of the product. This is subtracting logs of the same base, different numbers, the same as log of quotient. Now listen, quotient is the same as the value of 10 when you divide two numbers. So m is being divided by n. So we are saying log to base x minus log to base x of n, the same as log to base x m over n. Now I want you to tell me what
We can't hear you.
Leka amepotea. Wow. Select yuko. Sir.
Leka amepotea bwana yuko.
Lek yuko, amemute.
the net ilikuwa ipotea, sasa resumed. So I was asking, are you able to see the screen?
Yes, we are.
Yes.
Law number 2, subtraction dash quotient law, and this is what the law states. And I was asking you before the internet went off, what is log of 8 minus log of 2? Log of 8 minus log of 2. 4 decimal places.
0.602.
0.88.
No, listen. Log of 8 minus log of 2. I expect
0.602.
0.602.
0.602.
1.
1. That is 4 decimal places.
Yes.
Now, what is 8 divided by 2?
4.
And what is log of 8 now divided by 2? Same as log of 4. What is the answer?
Wenye wako na calc nini?
0.6021.
0.02.
Yes.
0.602.
So
0.6021.
yes, so we are saying the left-hand side is the same as the right-hand side. That's true?
Yes.
Because log of 8 minus log of 2 is 0.6021. That 8 divided by 2 is 4. So log of 4 is also 0.6021, isn't it?
Yeah.
Yes.
So the law is true, and under what condition? Just like the one for addition product, this is also what you are restricted to follow. The following should be noted about the law, the rule. And please note them, because we will find people make the same mistake which are warned here, and they are in bold red. The logs must have the same base, just like the other one. Otherwise, the log cannot be used. For example, if I have log to base 5, 32 minus that one cannot be the same as log to base 5 or 4. In other words, you are dividing 32 by 8, but discarding the log base. It is not true. Neither you discard the log but still divide but now put log to base 3. Neither of these is true. So, and we are saying the coefficient of the log must be 1. In other words, no other number is multiplying those logarithms. It is 1 times that, 1 times that. That is what it means by the coefficient of the log must be 1. The other one is say the logs for the addition, multiplication, or product log. We say number 1, logs was the same. Number 2, the sign between the values, the terms must be addition. Here, the second part is put here to show that it's single one log, not twice as the rest. That's why we say the coefficient of the log must be 1. Number 3, the sign between the terms must be subtraction and not division. Like I have log to base 2 of 50 minus log to base 2 of 10. The same as log of the combined ratio, which is log to base 2 of 50 divided by 10. 50 divided by 10 is 5. So if you look from your calculator, you can confirm that suppose you are reading this one. It means that, of course, from the calculator, you will not be able to get this directly unless you convert the base, but we shall show you later. This is the simplified part. But if I take log to base 2 of 50, divided by log to base 2 of 10, know the same thing. So the sign must be subtraction, not division. Just like the other one, the sign must be addition, not multiplication. This is what we have seen, and therefore, that is fundamental law number 2. The first 3 are the ones that are very crucial. We have the fundamental law number 3. Law 3, which we call power law. Law 3 power law. He says that if I have log to base x, now take it back from the indices, the power law we had a raised power m, then bracket raised power n, so it is the same as a raised power m times n. Is that true? From the indices point of view. Now the scenario is similar here. Log to base x of m raised power n. Now the index multiply the log, so I get n log to base x of m. I want to tell you what is log to base. What is 2 cubed?
8.
2 cubed is 8.
8.
Isn't it?
Yeah.
So log to base 2 to base 10. Just read log to base 10 of 8. What is the answer? Log of 8.
0.9031.
9031. 8 is the same as 2 cubed, isn't it?
Yes.
Then I want you to find now what is 3 times log of 2. What you are saying, log to base
0.903.
So I want you now to get past log of 3, log of 2, then times 3. 3 decimal, 4 decimal places.
0.9031.
0.9031.
9031. That is what we are trying to emphasize here. So when you have this kind of arrangement, we can always remember that I can get the log of the first number multiplied by the index. There are also other 3 special formula properties resulting from the above formula, so that if I have log to base m of that one is also log to base n. It is also the same as n, because we have to look at what we call the special case. log to base m of m is 1. So if you leave this one aside, let's look at this one because this one brings to avoid confusion. We just want to know that log to base x of m raised power n is the same as that. And then now we have what we call special or derived laws. That's where this part will come in. And therefore, we have, this is extended from the basic laws or fundamental laws. We talk about special or derived laws. Special or derived laws. If I have special or derived laws, the varieties that occur from that unity law. Unity law. Unity or log of unity, unity law. Unity is the same as 1. Log of unity, not unity of combination, but we have unity as a numerical value, so that from the indices, we have seen what is a raised power 0?
1.
1. So we are saying, what about if I get the log? This is what we are saying. Log to base x of 1 is always 0. From your calculator, I wanted to press log of 1. We are assuming you are using common logarithms. What is log of 1?
0.
Yes. We talk about unity log. Any base, you take log of 1 will always 0. Reason, in index form, x power 0 is 1. And the index is the same as the log. So we are saying logarithm to base x of any of 1 is always 0. So we are saying that the rule states this manner. The rule says that the logarithm of unity 1 to any base is 0. Yes, it is true because the power of that can be produced is exactly 0. This is according to the power of that. So this, so you can do whatever you want to scribble here. That is not mathematics. So that is first one. So we want to get the other derive this other part. Logarithm to the same base, 5. What I'm leaving is that no, the limits are they are not for our level. That's why you see me skipping them. Logarithm to the same base. The same base, we are saying log to base x of x is 1. Log to base x of x is 1 because we are saying that any quantity raised power x is a very quantity. Any quantity raised power x is a very quantity. So when I have to look at that theory from indices, yes.
Go back to, I'm stuck at special B. Derived laws, and then you're scrolling too fast.
I see, because I said they're not necessary for us. This is what I said. This one.
Okay. Yes.
The others are not have limits, and the rest not for us. That's why you see.
Okay.
Yes.
Thank you.
Yeah, the one that are in highlight there. This one, leave out negative, whatever. Those are not for our analysis here.
Okay, sir.
Yeah, that's why you saw me going to this number 5. Log to base x, the same base log, the same base log, the same base log. So we are saying log to base x of x is 1. The reason, from the index point of view, we have stated that when I have x to power 1 is a very x. Even if I look at your calculator, 10 raised to power 1, just press 10, then power 1. There's an inverted V symbol there, which will give you the power 1. It will give you a value of that, 10 raised to power 1. Is it 10?
Yes.
What about 8 raised to power 1? Is it 8?
Yeah.
1,000
8.
raised to power 1.
1,000.
1,000.
That's why we are saying log to be very value, and then the last bit is change of base law. Before we now come to another sheet to see how do we work with these rules or laws. Change of base law. Suppose I have to get log to base 3 of 7. Can someone tell us how would I get numerical value there? I want to use my calculator to get log to base 3 of 7. What would happen? This is where we talk about the change of base, because our calculators are programmed in a way that we can only use either log to base 10 or log to base E, but commonly we are using log to base 10. So we are saying if I have log to base n of m, the same as log to base x of m divided by log to base x of n. E.g., if I want to get, this is the rule, this is a derived rule. If I want to get log to base 3 of 7, the calculator does not give me log to base 3. Do we have it anywhere, any key log to base 3?
No.
No. So my option is, how conveniently can I use my calculator to use it to evaluate that? I can use common logarithms, which is log to base 10. So if I'm asked to evaluate log to base 10, log to base 3 of 7, then I can say numerator is log to base 10 of the first value divided by denominator log to base 10 of the second value, which was the log of the base. Therefore, I can go to write, you can write e.g. log to base 3 of 7 equals log to base 10 of 7 divided by log to base 10 of 3. Log to base 3 of 7 equals log to base 10 of 7 divided by log to base 10 of 3. Please take note that when I have log to base 10 of 7 divided by log to base 10 of 3, not the same as log to base 10 of 7 over 3. No, that is rule number 3, not applicable here. We are changing the base. So don't confuse them for computation purposes. I have to evaluate log to base 3 of 7. The calculator has got the keys which I can use, log to base 10 of 7 divided by log to base 10 of 3. Or even if I go to lane n, so it is lane 7 divided by lane 3. I'll get the same answer. So if I take you back before I go to further explanation, which is algebra, just press log of 7, then division sign, then log of 3. Leave your answer to 4 decimal places.
1.771.
1.7
71.
log 7 divided by log 3. 1.771. Yes. So we get 1.771. If I write 4 figures, 712, isn't it?
Yes.
Yes. Even if I go and press that lead, ln7 still divided by ln3. What do I get?
1.771.
Yes. So that is how to change the base so that we can have the same value for simplifying our work. So with that, we can look at some few example like here.
5, please.
Log to base 5 of 125 is the same as log to base 10 of 125 of that, the same thing, the same whatever value base you take, you can have the base will have denominator as a log, the number will have numerator as a log. So we can now shift and see how we can compute problems involving logarithms. Problems involving logarithms.
Yes, sir. Yes, sir.
Yes.
The example that you've given, log to base 5 over 125, why is the base in that example? Is the base changing? I've seen that example.
The base was changing. What I say, the base is not changing.
In the example that you're sharing in the screen.
Just a moment. You know, sometimes this is the language. We're going to have X stand for any number.
Yes.
Are you able to see?
Yes, I can see.
And whatever the base you take must be for both. Log to base 10, log to base 8, log to base 9. It will give you the same value. But log to base 8, and that one, we are able to compute, we shall have to rearrange. This one we can get directly from the calculator. Is that true?
Yes.
Yes.
Or even if I don't, I can say, but 125 the same as 5 times what? This 5 cubed?
Yes.
So log to base 5, without going with that one, log to base 5 of 125 the same as log to base 5 of 5 cubed, which is the same as 3 log to base 5 of 5. That true?
Yes.
Yes.
So that is what we are saying here. Note that the base keeps on changing is from the fact that we have this and that taken for both numerator and denominator. Are you getting that?
Yes.
Yes, that's what we are saying. So let's look at how can we get some part of this as illustrations.
Excuse me, mister.
Yes.
I'm asking, can you take 125 and divide by 5?
Can you?
Can that example you are showing, can 25, I use it to get a logo.
You're saying, can you take log?
125.
Yes, get 125 of 5. Press your calculator. What is the answer? Huh?
Those with calculator to assist, I don't have one.
I'm asking you, press your calculator.
I don't have a calculator.
I can't help now. Let's move on.
Please, can you pardon me on log 5?
What? The change of base. We had talked about log to base 5 of 25, 125, isn't it? No, you said, pardon you. Now you are silent. I don't know who I'm talking to.
Sir, I'm asking about log 5. I didn't get it well, please. Repeat it for me. Logarithm to the same base.
I want you to read. Are you able to read?
Yes.
And even I spent over 2 minutes explaining the index form. So if you can read, I think can be well, because the word is also there. Are you able to read comprehensively? This is the language we are using here. I start from here. My cursor is going on. If you can read, then the reasoning is given there. You have seen it?
Thank you. I get it.
Huh?
Yeah, I can.
You have or you can. There are two different statements.
I have, yes.
If you can see it, I want to see it. Okay. So this is where we want to, this is summary of that. If I want to ask you, because we want to use them, the laws of logarithms. From here, they are giving us index form, log form, laws of logarithms. So I believe we can write them down without being asked, please pardon me. We have explained this, of course, we are using different letters. What about the first one, log to base A of xy? What is the answer here?
Log to the base A x plus.
What is the answer there?
Log to the base A x plus log to
I hope I was not singing
y.
in the bush. We studied so well, the laws of logarithms. What is the answer there?
Log to the base ax plus log to the base ay.
Abdikadir, can you tell us?
Log to the base ax plus log to the base ay.
Huh?
Log to the base ax plus log to the base ay.
So we say log to base A x plus log to base A y. I thought I what you meant. Is that true, Abdikadir?
Yeah,
What,
it is.
Yes, sir.
what about log to base A? Log to base A of x now divided by y.
Log to base A x minus
Log to base A of x minus
log to base
y of y, isn't it?
Yes.
Good. Now, because we want to look at some demonstration exercises there, what about this? Log to base A, x power m.
M log A M log A
M times log to base A of x. Isn't it?
Yes.
Yes. So now with that foundation, so equation involving logarithms, log to base A, then we can now put them. If log to base A of x to log base A of x, then if log to base A, look at this other statement. I believe in my heart we keep note of that, because what is coming out, we are just watching a film and not noting anything is substantial. Like some will tell you, I don't have a calculator. How can the lecturer help
Net N.
Hello.
Jack Abraham Deng, when your host?
Kwani moja ameandaje?
Jack, hebu jibu hiyo swali.
Cheki, mimi si host.
Walai, angalia wewe ndio host.
Walai wewe ndio host manze.
Kwani kumeenda aje?
Wewe tuambie, wewe ndio host.
Mimi sijui.
Si class imeisha hivyo basi.
Ilisha hivyo manze. Sasa kuna otherwise.
Alafu warudi.
Saa 5 iko.
Saa 5:15. Sasa saa 5:15.
Wacha.
Acha tupate hii time to prepare man. Mimi hata ndo niko Kayole hata niko Berka.
Wewe host.
Kwani kunaenda aje?
Wewe ndio host, tuambie baba. Wewe ndio host.
Lega amesema mtumie hiyo time prepare mwende class nyingine.
Umejua aje amesema hivyo?
Tumia akili si hayuko.
Kwani kumeenda aje?
Asha left.
Ameenda kuunda hiyo quiz.
Ameenda kuunda quiz kesho. Wewe Abraham.
Jina Jack Abraham wa nani? Jack Abraham Deng. Wewe ndio host man. Tuambie ni nini endelea.
Mimi sijui.
Sijui na wewe ndio host.
Bana.
Nimejipata tu hivi.
Wendo login na mwalimu.
Kwani kunaenda aje?
Left bana, class imeisha hivyo ama.
Wewe father uko ndani ku left to left, hatuja kufika mguu.
Basi ndike madosi huko.
Left tuende hiyo Darunengo. Sita kuna. Kama wale tunacheka hiyo ndio host.
Msikike kwa hiyo audio hii.
Basi umesema
Imeisha hivyo ama? Inaisha na hajatuambia na SD.
Ndio amerudi.
Not that I disappear, my friend. It's the net. These are not my making, eh? Just
yes,
sir. Yeah, you know, it is very unfair that I just disappear as if I'm a witchcraft. So, Yeah, so it's this technology that is actually on and off. That's what is causing all these problems. So I was saying, are you able to see now?
Yes.
Yes, yes.
Yeah, so from here, I was saying, if log to base A of x equals that one, then we can say x equals y, right? That one down. These are summary of the facts that we need to know about logarithms, just like we did also with indices. If x, because we are taking logs both sides, it means you are dropping logs, so you say x equals that. Now, change of logarithm, change of base, log to base A. If log to base A equals that one, because that one is the same as log to base x of b divided by log to base x of a, isn't it? So we can talk of x standing for any log, and then we move on for the change of base. Let's look at this some illustrations here. Let's look at that. These are what we want to work on as illustrations. So logarithms and laws of logarithms. Now, if I look at this one, there is a working that is showing here that you can use. I can use the method the author is writing here, or I can use another method. He's saying that let log to be now. If we say let log to base 4 of 1 over 64 be equal to x. From the indices point of view, this is the same as saying 4 to the power x is 1 over 64. Of course, he has jumped one step here. 4 to the power x from log to base 4, that equals x. This is the same as 4 to the power x equals 1 over 64. And 64 is the same as 4 cubed. That is the same as 4 to the power x equals 1 over 4 cubed, or 4 to the power x equals 4 to the power negative 3, giving us x equals negative 3. That is what they are saying here. From the index point of view. From the index point of view. Now, I want you to take note that the same approach, the same sum can be done this way. I you see where it is marked log base 4 of 1 over 64? You see where it is marked log to base 4. If I don't use this method, because this is now by equating the indices, I can still go without forming the equation by writing first case step is log to base 4 of 1 over 64. This second stage, 64, we have said is the same as 4 cubed. Is that true? Samuel Mwangi, is that true?
Yes.
So the next step I can write is the same as log to base 4 of 1 over 4 cubed. So instead of 1 over 4 or 1 over 64, I write 1 over 4 cubed. And 1 over 4 cubed is the same as 4 raised power negative 3. So I have second stage log to base 4 of 4 raised power negative 3. Log to base 4 of 4 raised power negative 3. By the rules of logarithms, there is power rule, and log to base 4 of 4 raised power negative 3 the same as negative 3 times log to base 4 of 4. Negative 3 times log to base 4 of 4. We also have the same logarithms rule. What is log to base 4 of 4?
1.
And what is 1 times negative 3?
Negative 3.
Negative 3.
So I still get the same answer by not going to put it to x, just using the same value, and I get that. So this one is a misprint. The next one is should be log to base 5 of root of 5. Not is equal to. They cannot be called mathematically true. The second one is should be written as log to base 5, then root of 5. Log to base 5, then root of 5. That is why they are putting log base 5 root of equals x. Yes, you can now put this equal to a half. Or if I use the same style I've used for this one without equating to x, I can have it this way. Log to base 5 of root of 5 the same as log to base 5 of 5 raised power half. That's the same as log to base 5 of 5 raised to power 1 over 2. If that is true, by the power rule, rule number 3, that's the same as a half log to base 5 of 5. By the power rule, that's the same as a half times log to base 5 of 5. So log to base 5 of 5.
The answer is 1.
Yes, 1. And 1 times a half is a half, isn't it?
Yes.
So that is how another method of getting this. We have to find the value simply by using laws of logarithms. There's this one, which is now equal log to base 2 of x equals negative 5. This is just calling on us to rewrite a number from log form to index form, which can be written as x equals 2 to the power negative 5. And 2 to the power negative 5 is the same as 1 over 2 to the power 5, which is 1 over 32. So x is 1 over 32. There are some I want us to look at here together. Let us see. Let's look at 1 and 2. I give you 4 minutes. Evaluate that number 1 and 2. Where it is written, find the value of each of the following, number 1 and 2. The secret here is that as we have this, it is a matter of rewriting the number given as an index form of the smallest possible prime factor or number that is involved there.
Seven.
Yes, we have found number 1.
7.
7. Because 128 can be written as 2 to the power 7. Is that true?
Yes.
And therefore, I can write log to base 2 of 128 as log to base 2 of 2 to the power 7. My power rule is the same as 7 times log to base 2 of 2. Do we agree there?
Yes.
Yes, that is good. What about part 2?
Number 2x is equals to 3 over 2.
3 over 2. Because 125 is the same as, first of all, log to base 5 of root of that was the same as log to base 5 of 125 raised power half. Do you agree? And 125 the same as 3 cubed. So we have log to base 5 of 5 raised power 3 over 2, which is by the power rule, 3 over 2 log to base 5 of 5, which is 3 over 2, as my sisters said it. Good. This other one, let's look at this last two before I give you other to work. Let's look at 3 and 4. Three and 4.
H2.
Yes, negative 1.19382. Mogi, what are you trying
Can
to
you
draw?
explain?
Can I explain or we
Can
work
you
it out?
number 4?
Explain,
Yes.
sir.
Explain
Yes,
number
can somebody explain to us? Not me. We are in class, so we both try.
Okay, you work it out as you explain.
The author can tell us. And not
Also
only
explain. Also explain number 3.
The author can explain to us. What is the connection between that one, the first lady? What's the connection between 64 and 8?
$64 is the same as 8 power 2.
No, the lady who is very bitter and asking. Also explain number 3. What is the connection between 8 and 64? Okay, does not want to talk. We go on. Number 4, somebody was explaining.
Explain number 3.
You want to explain number 3? Yes.
This is
Number 3, can you give us the explanation? Duncan Oguchi.
Yes. Yes.
Can you explain to us? Duncan? Go ahead. Mashira, this is Mashira Duncan Oguchi. Tell us. Duncan, you have to explain. Who else can explain to us? Okay, Ali Amos Kagwa.
So 64 is the same as 8 power 2.
Yes, 64 is the same as 8 power 2, which is 8 squared, yes.
So it will be log 8, log to base 8, 1 over 8 power 2. Then 1 over 8 power 2 can
And
be written.
1 over 8 squared is the same as what? In negative index?
A negative 2.
What?
Yes, 8 power negative 2.
1 over 8 squared, as if I don't go for a reciprocal, is the same as what?
8 power negative 2. Is it the same as 8 power negative 2? Sir. Sir. I will host one.
Here they have been thrown off. He has to come back. Class.
Oh. I was saying 1 over 8 squared is the same as 8 power negative 2.
Negative 2, isn't it?
Yes.
And therefore, what is log to base 8 of 8 power negative 2 is the same as negative 2 times log to base 8 of 8.
Yes.
Yes, sir.
That answers our sister who went now quiet.
Excuse me, sir.
Explain. So negative 2 times 8, you get that. Mark Kijwa.
Excuse me, sir. Excuse me, sir.
Yes, Mark Kijwa, I'm hearing you.
Okay, can you solve that question with law 6, that is change of base law? That also have used.
5.
Yes?
Can you Can you solve number 3 using the law 6, that is change of base law?
Not necessary.
But that's what I've used. Despite the fact that one of us...
Okay, if you have used it, it is the same as log, because you are saying log to base 8 of 1 over 64. Isn't it?
Yes.
Okay? 8. So how have you used your change your base?
Okay, now I'll say log to base 10 or 1 over 64 or divided by log to base 10 or 8.
Okay. It should give you the only thing that is now we made it complicated. So we simply go by the rules of that one. It will give us that. You are saying log to base 10 over
Wait, host. Abraham.
Bana, Father Abraham bana.
Ewe cheki. Usijui najipataje hivi.
Will the host, Daddy, will the host.
Hii class inaisha when?
Saa tano Tuesday. Shit. Wait, Father Abraham.
Yeah, acha zako wewe.
Hebu tuentertain kidogo.
Manze, Father Abraham, manze. Si utuambie rada ni gani manze.
Yes, bana.
Mjibu kwa sura yenu.
Abraham ongoza kikosi.
Abraham de. Rada ni gani bana?
Abraham host manzi, rada ni gani?
Lewa.
Bana nyima wasemu kwa makejani. Hizi ni gani?
Kwani wewe ushafika chuo? Kwani nani alikwambia watu wanakuja shule saa hii?
Ati
nani alikwambia watu wanakuja shule saa hii? Wewe ushafika chuo?
Tumia CCTV.
sema hivyo tena imebaki 30 minutes bro.
Haina mambo, acha ibaki hata 10.
Ya, hapo basi.
Tena tumia CCTV.
Wewe.
Nataka kuendea breakfast. Ish.
Uko makajani?
Tuende.
Cheki wase, tumia ni time imebaki manze tu prepare tuende mchuo.
Wewe deng bana, simalize hii kitu tuishie.
DJ Bushmix. Chuko powerful. Nothing to discuss, cause I think when you buy powerful to this. Nothing to discuss, powerful to this out. Powerful to this out.
Manze niweka ile bao ya Anthony versus Arsenal.
Admin. Host. Abraham, hebu tusaidie walai.
Nene melewa number 4.
By the way, hiyo number 4 mi napata negative 1.79. Is that the correct one?
By the manze mtu anajua hiyo number 4 sipata tusho. Hadi sielewi ya ini.
Yeri nyinyi wenye mko na kalk.
Kuna floaters hapa.
Last time model sema mkuje na calcs ni 1 week. Hii unit tunga tunafundisha once a week.
Sasa tukuje nao wapi na tuko maeria? Tukuje nao wapi?
Sasa unatafuta calcs kwa nayo ni nini?
Sasa kesho ni cut. Bila calcs ati.
Kesho ni leo.
Bro, si kila mtu anapenda football, sawa?
Cheki si replay ile Arsenal versus Manchester ile Arsenal versus Manchester hizi.
Man U na Arsenal si nini ya
Liverpool, Man U na Arsenal.
Man U ishati.
Hebu tafuta video nyingine wewe. Si kila mtu anapenda football.
Check
Na Medina na cartoon bana.
Tafuta logarithms hapo YouTube.
Bas.
Check Manchester versus Arsenal. Si bana, hii ni versus nini Omonia.
Huko si
Arsenal.
Wewe. Eka logarithm. Acha mchezo.
Hiyo sasa hiyo.
Eka logarithms. Hebu type hapo logarithms.
It's a very vast field.
Sasa Zoza Nation Magitango. Like ametoka unaweka omoroto.
Bana ngano kok dwa keto gigo to we bwana, ngano kok dwa keto gigo to we.
That's
Bana ketwa gi mwadwaro bwana, okidi ketwa gi main midwaro, ketwa gi mwadwaro kok man kwa 340 like.
So, si lazima ushare screen yako. Hata tusikii kitu. Sasa fanya tu hivi. Itoe tu.
Lazima tusikie kitu.
Itoa tu.
Cheki basi kama umeshindwa kuweka hiyo, tafuta hapo prince ndio tuweke manze.
Excuse. Lecturer Harud class, you're supposed to go for your next class.
Who are you?
Wani nani
Wenyewe. Wewe unajiona nani?
Okay, for those ones to go to the next class, you can leave the meeting.
Who are you to tell people to leave the meeting? Kwani wewe ndio host? Kama host mwenyewe ajui yeye ni host, kwani wewe ni nani man? Si tuambie wewe ni nani na umeambiwa tuambie nini?
Bro. Zi. Acha chuki.
Goja, kwani Charity ndio class rep wa hii nini?
Wewe acha kide.
Nani alimchagua class rep ya hii nini?
Charity.
Nani mweka? Hiyo ni utoto bana.
Bana tuweke prince tutanga. Tutaka kuprepare manze.
Charity ndevele.
Sedekeni ya Viambo.
Kwani wewe ni Adhiambo, yeye unataka kujichezewa Adhiambo.
Tunataka mama watoto.
Na huyo anajenga hapo.
That is a big problem here.
Oh, sir, welcome back.
Big problem.
Welcome,
that is what is causing us not to move. So we were at that point. So let me.
Sir? Father Abraham, ongoza.
Ndio watu wame left, tumebaki watu 90 ngapi out of 180. 188.
Austin. Aseo rogigo.
Ekege bwana akona hiki. Ikmiorogo hiki.
Papa kama. Ati?
Ni oro nwako si oro nenga.
Aoro ne jama moro menosiepa.
Oh, sawa. Wambe temi oro nwa moko.